When you have to construct and interpret diagrams of continuous and discrete data, there are two main ones you need to learn. Histograms, which we'll deal with separately, and cumulative frequency diagrams. We're going to look today at cumulative frequency. So here I have a table. I have drawn a table. It's a group data table. So it's saying time in seconds and frequency. The first column, 0 to 10, so there are 14 people between 0 and 10. This is about how long it takes to answer 100 calls at a call centre. When we're finding our cumulative frequency, the word cumulative effectively means build up. So for my first cumulative frequency, I'm looking for what are the frequencies in just the first column. So it's obviously 14. For my second one, however, I'm looking for all of them between 0 and 20. So I need to look at both frequencies. That will give me a cumulative frequency of 46. I just keep going. You can see where this is going. My next one, I'm going to add another 36 in. So I've got 36 plus 32 plus 14, which will give me 82. I then use 10, giving me 92, and the 8, which gives me 100. It's a really useful thing to check here that that last number is the same as the one you've got in the question if you're given one, because you know then you've probably done it correctly. We're now going to look at this table and we're going to plot it. So I've got a little axis here. One thing you must remember, any frequencies, irrelevant of what they are, always go up the side. So this one, the cumulative frequency, has to go up the side, and my other term, the time, has to go along the bottom. I'm going to plot these. The biggest mistake people make when they do cumulative frequency diagrams is they plot them at the wrong place. So these are the values I'm going to use. My cumulative frequency of 14 is going to be plotted at 10 because it is everything up to and including 10. So I'll get a nice little point there. I'm using a cross once again because it is easier to see what you've done when you've drawn over it with your line. I've done my 14, I'm now going to look at my 46. This is everything that is up to including 20, so again I plot it at the top point, that 20. So it's going to be 20 times 46 cumulative frequency, giving me a point there. Then the next one is going to be at 3082, 4092 and 5100, and I'm going to join them up. I've joined them up with straight lines. Technically it should be joined up with a curve. However, you will get full marks if you draw them with straight lines. In fact, the examiners are expecting you to do so. The questions are built to give you nice answers if you do. It's a lot easier to join them up with straight lines than it is to do a curve. Just make your life easier. The other thing I get asked is, should I join it to 0 at the bottom? And the answer is not always. Sometimes you should, sometimes you shouldn't. However, you will never lose marks if you don't. So again, to make sure you're not going to make a silly mistake, don't join it up. You will notice that this curve has a very distinct shape. It gets steeper and then shallows off. It should look something like this. The other big mistake that people make is they get a graph that looks like this. If you've done that, if you've done it properly, you've used the cumulative frequencies. If you want this other shape that gets bigger and then comes down to the bottom, you've actually used the frequencies. So you do need to therefore do it again. Once we've drawn it, we need to interpret it. We need to read values off it. The main reason we do cumulative frequency diagrams is so that we can find an average and a measure of spread. One number that represents the whole set of data, and one number that represents the consistency. Our median is the one we use for our average because it is ordered data. Now I've got 100 calls, so therefore my median is half of that, is 50. So I'm going to look from my cumulative frequency of 50 across to my graph. I'm going to drop a line down. I'm going to get 21. My average is 21, my median. I'm now also going to find my interquartile range. Now quartile means quarter and range is biggest take smallest. So I'm going to look for the biggest quarter, take away the smallest quarter. Now we call them the upper quartile and the lower quartile. Now my upper quartile is my top 25%. So if I've got 100, my 25% therefore means I'm at 75. I'm taking the top 25% off. I've drawn a line across, I'm going to drop it down. reading the value off should give me upper quartile of 28. We do the same for the lower quartile, but obviously it's the bottom quarter. So the bottom 25% in this case is going to give me 25. It's not always 25. It's going to depend on what you've got. So if you had, for example, 80 pieces of data rather than 100, your median would be at 40, your upper would be at 60, and your lower would be at 20. But ours is 25. So I draw my line across, I drop my line down, which will give me a lower quartile of 14. Interquartile range, upper quartile minus lower quartile gives me interquartile range of 14. The other thing that they will ask you to do is ask you to read off from the other axis. So how many people waited more than 35 seconds? So 35 seconds on the bottom is there. So I draw my line up to my line, I draw across, that gives me a value of 88. The common mistake people make here is they put 88. It says how many more than 35 seconds, so therefore it's what's left. I've got 100, 88 are below 35 seconds, so therefore 12 people waited more.